Okay. Is it visible? Hello?
Yes, ma'am.
Okay. Okay. Today we learn about the operators and expressions. Unit 3. We have already completed the first two units. These operators and expressions are very important as per the programming concern. Uh, in each and every languages, the operators and expressions are used. So first of all, you understand what do you mean by the operator. Operator is a symbol that tells computer to perform some arithmetic or logical operation. Operators are used in a program to manipulate data and variables. Means if you want to do some operations on the data and variables, then in that case, you have to use the concept of operators. It takes one or more arguments and operates on the operands to produce the result. Don't confuse. Operator means a symbol and operand means the value on which the operator performs the operations. Okay. Now the operators in C language are classified into the following number of categories. Uh, the first category is the arithmetic operators, relational operators, logical operators, assignment operators, then compound assignment operator, increment and decrement operators, conditional operators, bitwise operators, spatial operators, and size of operators. So the C language provides you lots of operators or the lots of categories, and such a number of categories are may not be available in other languages. So the C language is rich to provide the operators. Now we see one by one each category. The first category is arithmetic operators. Okay, arithmetic operators. So all of you aware about the concept of arithmetic. What do you mean by the arithmetic? The general word. The arithmetic consists of the addition, subtraction, multiplication, division, means all the basic operations belongs to the word arithmetic. So the arithmetic operators are used in the mathematical expressions. Obviously, as these operators are the plus, minus, multiplication, division, modulo, all these operators generally used in the mathematical expressions. These are used to perform some mathematical operations like addition, subtraction, multiplication, division, and modulo. Modulo means to, if you want to find out the remainder after the division, in that case you have to use the concept of modulo operator. Okay. Here I have given one example for each and every operator. So for that, assume the values of the two variables. The value of first variable x is a 20 and the y consists of the value 40. Means 20 is assigned to the x and 40 is assigned to the y. So the following table shows you the purpose of each and every operator along with the description and the example. The first operator is addition. So it adds the values on either side of the operator. And the example is very simple. X plus y, that is equal to 60. What is x? The value of x is replaced with the 20 and y is replaced with the 40. So 20 plus 40, that is equal to 40. This adds the values on either side. Either side means you either add x plus y or y plus x, because the addition is always commutative. So the next operator is the subtraction operator, and the subtraction operator is minus. The minus sign is generally used for the subtraction. What is the purpose of subtraction? It subtracts the right hand operand from the left hand operand. Which is the right hand operand? Y. That y is subtracted from the left hand operand, that is x. What do you mean by the operand? Operand means x and y are called as the operands, and this symbol is called as the operator. So don't confuse between the operand and the operators. X and y are the operands, and this one is the symbol, plus, minus, multiplication, division, percent symbol. All these are called as the operators. Then next, and similarly, you will get the result minus 20. Why you get the result minus 20? Because x minus y means x equal to 20, 20 minus 40, and that is equal to minus 20. Because the sign is always preceded of, with the larger number. So that's why you will get the result minus 20. Multiplication, the symbol of multiplication is star, and it is also called as the asterisk. What is the role? Multiplies the values on either side of the operator, means x into y or y into x, and it will produces the result as a 800. 20 into 40, that is equal to 800. The next operator is a division operator. So all of us are very aware about all these basic operations, plus, minus, multiplication, and division. So division operator just divides the left hand operator by the right hand operator. The left hand operator is a y divides the x. What is the value of y? Y is the 40. So 40 divided by 20, that is equal to 2. And the last one operator is new for you, that is a modulo division. And the modulo division is generally indicated with the symbol percent sign. What is the role of modulo division, or does what it do? Modulo division, it divides the left hand operator by the left hand operand by the right hand operand and returns the remainder. Okay, why? What is the value of y? 40. 40 modulo 20 means 40 divided by 20, and the remainder is 0. Division is 2. 22s are 40, means the division quotient is 2 and the remainder is 0. So if you want to find out the remainder after the division, then you must use the modulo operator or modulo division operator. And remember that the modulo operator can be operated only on the integer values, not on the real values. If you use the modulo operator for the real values, then computer gives you the error. And most of the time this question may be asked in the examination as a MCQ. The modulo operator can be operated on the following data types: integer, float, or character, or double. So the correct option is the integer. So it should be noted that the modulo operators can be operated only on the integer values. Okay, clear? The basic operators, arithmetic operators. Now the next category, so before going to the second category, first of all you understand the concept of the expression. What do you mean by the expression? The expression which contains only the arithmetic operators is called the expression. And see, in the last uh, slide, all these are the expressions. X plus y equal to 60, x into y equal to 800, y divided by x equal to 2. All these are the examples of expressions. So expression is nothing but it is the combination of operands and the operators. Okay. So arithmetic expressions can be of the following types. There are the two different types for the arithmetic expressions. The first one is the integer arithmetic, and the second one is the real arithmetic, and third is the mixed mode arithmetic. So out of which the first expression is the integer arithmetic. The word indicates its meaning. Integer arithmetic means all the operands in an expression are only the integer values, not the real values, and that's why it is called as the integer expression or integer arithmetic. And remember, the result of integer expression is always the integer value. See the following some expressions: 3 plus 5 minus 2. 3 plus 5, that is equal to 8. 8 minus 2, the result is 6. So the result, all these are the integers, and if you compute, then result is again the integer. 10 divided by 3. 3 threes are 9. So the quotient is 3. Again it is the integer, 3 point something. But it truncates the fraction part, means it truncates the digits after the decimal point, and that's why you will get only the 3 here. Why? Because the division is integer division, and that's why the result is again the integer, not real. And if the result is real, then it truncates, it removes the fraction part. 6 divided by 7. So again, here the 0 point something, but the result is always integer, and due to this, the fractional part 0 point something that will be truncated, that will be removed, and the result is only 0. During the modulo operation, sign of the result is always the sign of first operand. You should remember, in case of the modulo division, always remember that the sign of result is always the sign of first operand. And see, this is the first example, minus 14 modulo 3. What is the first operand? Minus 14. Okay. And what is the second operand? 3. So after the modulo division, the remainder is 3 4s are 12. 14 minus 12, that is equal to 2. 2 is the remainder. And which is the sign? The sign is always the sign of first operand. The first operand is negative number, and that's why your result is again negative. Okay. And see the second example, exactly reverse. 14 modulo 3 minus 3. Okay. Again, you will get the same answer 2, but here is a difference of sign. This 2 means, why this 2 is a plus value? Because your first operand is a positive operand, and that's why here you get the result as a plus 2, and in the first example minus 2. Okay. Hello, what is the problem? Am I audible? Hello, hello,
Yes,
Ganesh,
ma'am.
am I audible?
Yes, yes, ma'am.
Okay. Now the second category of expression is real arithmetic. Okay. Again, real arithmetic means all the operands are the real values, and that's why it is called as a real arithmetic. The result of real arithmetic expression is always a real value, like the previous one. The result is again the real. And see the examples, 5.2 plus 1.2, that is equal to 6.6. This is the real value. Real value means what? The value which consists of the decimal point, or the value which consists of the fraction part. Okay. Then 10.0 divided by 3.0. Again, you will get the real value 3.33. And for the last division, 6.0 divided by 7.0, again you will get the real value 0.85. Why you get the real value? Because this is a real expression, and that's why you will get the result again real. If it is an integer, then you will get the integer value. And the third category is mixed mode arithmetic. What do you mean by the mixed mode? Mixed mode means it is the combination of integer and the real expression. See, the result of mixed mode arithmetic expression is always the real value. Though it consists of, or though this expression consists of the some values are integer and some values are real, but always your result will be the real value. And see the expression 15 divided by 10.0. What is 15? It is an integer value, and 10.0 it is a real value. And you will get the answer 1.5. Okay, means the real value. Now the next category is the second category of operators is the relational operators. Relational operators, all of you know that the symbols less than, greater than, less than, equal to, greater than, equal to, and equal to. So all these symbols are called as the relational operators. Now the question is, when we have to use the relational operators. So in most of the situation, you require to take certain kind of decisions. So in that situation, you have to use the relational operator. Situation means either yes or no. In that case, you have to use the relational operators. Okay. Or if you want to compare the values of the two variables for the various purposes, the relational operators are used. After comparing these values, we may take the several decisions in the program. And these operators are also called as the comparison operator. Relational operators, the synonym of relational operator is the comparison operator. Why these are called as the comparison operator? Because you have to compare the two values of the two variables or the more than two expressions, and that's why it is called as the comparison. So these are in the table. You look in the table. There are the various relational operators. The first operator is the equal to operator. That equal to operator is remember that not a single equal sign. It is a double equal sign. The equal to operator is represented with the symbol double equal to. And the explanation is a very simple. It is used for check the equality. And just I have taken here one example. 5 is equal to 5. Is it correct? 5 equal to 5. Is it correct? Yes or no? Is it correct? Hello?
Yes,
Unmute.
ma'am.
Okay. It is correct. And that's why the result written by this expression is true. See the second example, not equal to. And this is the symbol of not equal to, exclamatory sign and equal sign. It is generally used to check the inequality of the numbers. And here I use the same example, means the same value. 5 is not equal to 5. 5 is not equal to 5. False, because 5 equal to 5. It is a true. So not equal to false. This sign is the third, see the third row. This sign is represented as a greater than symbol, greater than operator, and it is used for check the greater value. 5 is greater than 5? No. 5 is not greater than 5, and that's why you will get the result false. The next one is a less than operator. It is used for, it is used to check the less value. 5 is less than 5, again it is false. But if I use the symbol instead of less than, greater than and less than equal to, then you will get the result true. How? See, this is the symbol of greater than or equal to. It is used for check greater as well as equality. Means this greater than equal to operators check for the greater value as well as the equal value. And now here 5 is not greater than 5, but 5 is equal to 5, and that's why you will get the result as a true. Okay. Now the last operator is less than or equal to. So it is used for it is used to check the less value as well as the equality value. 5 is less than 5 is false. But if I used here 5 is less than or equal to 5, it is true, because both values are equal, and that's why you will get the result as a true. So this is about the relational operators. So you remember that the relational operators are called as the comparison operators, and generally for comparing the values we use the concept of relational operators. Okay. Now the next category, sorry, before going to the next category, expression. Again, what do you mean by the relational expression? The expression which contains the relational operators is called as relational expression. The result of relational expression is either true or false. If it is true, then it will return the value 1, and if it is false, it will return the value 0. These are some examples of relational expressions. The first example, see here, 4.5 is less than or equal to 10. Yes, obviously, the 4.5 is less than 10, and that's why you will get the answer as a true. True means digitally it is 1. The second example, minus 40 is greater than or equal to 0. It is a false, because the negative value, minus 40 is the negative value, and negative value is not greater than the positive value. So that's why the result is false. And the last example is 7 is less than or equal to 7. You will get the result again true. Why? Because the 7 is not less than 7, but 7 is equal to 7. And that's why you will get the result true. Okay. So relational operators are used in decision making statements such as if statement. Okay. In the next unit, we learn about some statements which are required for the programming: if statement, if else statement, while, do while, and for loops. So in that situation, the relational operators are used. The next category is logical operators. What do you mean by the logical operator? when we want to form the compound conditions by combining two or more relations or combining two or more expressions, then we can use the logical operators. Means if you want to combine multiple expressions, in that situation you have to use the logical operators. Means suppose for example x is less than 5 and y is greater than 6. So x is less than 5 is one expression and y is greater than 6 is another expression. And just I have to combine these both expressions with the AND operator. Similarly, you can combine with the logical OR operator, or you can use the logical NOT operator. So for combining the two or more relations expressions, you can use the logical operators. These operators compare or evaluate logical and relational expressions. Okay, means as you use the logical operators within the expression, then that expression also consists of some relational expressions or relational operators. So there are only three logical operators which are related with the logical decision. And assume that here x consists of the value true and y variable consists of the value false. And accordingly, I have given the following examples respect with respect to all the various logical operators. See the first operator. The first operator is logical AND operator. This logical AND operator is represented with the double ampersand symbol. And what is the purpose of that logical AND? Both the operands are non-zero, then result becomes the true. Means you in the next slide, I will take on in detail. You just remember here the operator symbol and the example. X and Y, that is false. X means what? X consists of the value true and Y consists of the value false. So true and false, false. Then next operator is a logical operator. It is represented with the double pipe symbol and result becomes true if any two operands are non-zero. Any two operands means either any one operand. So x or y, what is the value of x? The value of x is true and the value of y is false. So true or false, that's why you will get the result true. Okay, and the last one is the logical NOT operator. You remember that the logical NOT operator is the unary operator and it takes only the one operand, and that's why it is called as the unary operator. And generally it is used to negate the condition. If the condition is true, then the logical NOT operator will make it false. If the input is false, then it will give you the result as a true. And all these operators you will get clear in the next slide. One by one. The first operator is the AND operator. Okay, just I already told you in the last slide. It is represented using the double ampersand sign, or you can say the AND symbol, double AND symbol. Hello, hello. What is the problem? Hello. Am I audible? Divya? Hello. Prajakta? Am I audible?
Yes, ma'am.
Okay.
Yes.
Shall I continue? Yes. It's general. And what is the syntax? The syntax of AND operator is OP1 and OP2. OP1 means what? The first value. Means operand. This is a short form of operand 1. And OP2 means short form of operand 2. Means the value 1 and value 2. Okay. It is a binary operator. Why it is called as the binary operator? Bi means 2. And this operator requires the two values to operate or to perform the operation, and that's why it is called as the binary. The working of this operator can be explained with the following table, and this table is called as a truth table. I think all of you have learned in the electronic subject, 12th electronics, operand 1, operand 2, and operand 1 and operand 2. Okay, here I have given the various inputs. In the first case, I have given the input as a first operand is 0, and the second operand is also the 0. And then I get the result as a 0. Why? You consider that one short form of and means multiplication. And you know that 0 into 0, 0. This is a shortcut to remember. So you remember the and means multiply, or means plus. So 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. And when you will get the output 1, if both the operands are 1, both the operands are true, then you will get the result true. Okay. The result of logical AND operator is 1 when both the operands are 1. Otherwise, it will return the 0. Means any one of the operand is 1 and any one of the operand is 0, then you will get the result 0. Clear? Now the next operator, OR operator. This OR operator is generally represented using the double pipe symbol, double line symbol. Its general syntax is OP1, OR operator, and OP2. Okay, OP1 and OP2 are again the operands. It is again binary operator because it requires the two operands for its working. And this is the truth table of OR operator, operand 1, operand 2, and this is the result column OP1 or OP2. And in short, you remember OR means plus. So 0 plus 0, 0. This is a very short way to remember. Otherwise, we have to remember the rules. If both of the inputs are false, then you will get the result false. Or if any one of the input is false, then you will get the result true. So instead of that, you in short form, you remember that OR means plus. And it's very simple. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1. Okay. The result of logical OR operator is 1 means true when both the operands or any one operand is 1. See here, when both the operands are 1, the last case, last row, 1, 1, 1. Or any one of the operand is 1, see the second and third row. This operand is 1 and here the operand 1 is 1 and you will get the result as a 1. As it performs the operation like the addition, you will get the result 0 only when both the operands are 0. Okay, clear? And the last remaining only one operator of the logical category, that is not operator. This operator is the unary operator. This operator is different than the first two operator. The logical and logical OR, these two operators are binary operator. And bi means two because they requires the two values, two operands to perform the operation. But this is not in the case of not operator. This not operator is called as the unary operator. Unary means what? Unary means one. This operator requires only one operand, only one value to perform the operation. And that's why it requires only one operand for its working. The general syntax of not operator is the not operator is represented using with the sign exclamatory mark. This is the exclamatory mark, and remember that this exclamatory sign represents the not logical not operator. This symbol and OP1. OP1 are you can just write here the OP means only one operand, and this is the truth table. The output of the logical not operator is 1 if the input is 0 and the output of not operator is 0 if the input is 1. If you carefully observe, then it is noticed that this operator gives the complement of input. See here, what is the input? Input is 0 and 1 is the complement, means exactly invert the input. If it is 0, then output is 1. And if input is 1, then output is 0. Means exactly it complements the input. And that's why it is also called as the inverter. Why it is called as inverter? Because just it inverts the input. If the input is 1, then the output is 0. Or if the input is 0, then the output is 1. And that's why it is called as the inverter, or the complement operator. Okay, we stop here. In today's lecture, we learn about the arithmetic operators, relational operators, and logical operators. So out of these three categories, the arithmetic operators are the binary operators, relational operators are also the binary operators, and logical and logical are also the binary operators, because all of these operators requires two values to perform their operation. Only one operator is the unary operator, and in most of the time there may be the possibility of asking the question on this topic is which one of the following is the unary operator, and the multiple choices are just like the logical not, then logical and, then plus operator, then less than operator. So which one is the correct which one is the correct option? The correct option is logical not. So such kind of the questions are asked in the examination as a MCQ pattern. So you keep in the mind only one operator is the unary operator. And now here we stop the lecture. If you have any problem,